Hello everyone. Now let us start your exercise 7.2. But before starting this, there is a theorem on page number 121. Okay, see, the first concept is about isosceles triangle. You know what do you mean by isosceles triangle? A triangle having two sides equal, that is called isosceles triangle. Left triangle is ABC. If AB and AC are same, we said what? It is an isosceles triangle. If AB and BC are same, then also isosceles. AC and BC, then also isosceles. It means out of the three, any two sides are equal in measurement, then the triangle is known as isosceles triangle. Now on the base of this isosceles triangle, there is a theorem number 7.2. So theorem 7.2, angles opposite to equal sides of an isosceles triangle okay, angles are always equal. See, isosceles triangle is given. Here you are going to prove what? Angles opposite to equal sides of an isosceles triangle. A triangle is given, two sides are equal in given, okay? It means what? It is an isosceles triangle. Prove that their opposite angles are also equal. Let triangle ABC is there. Two sides are equal, that's why it is an isosceles triangle. Here we consider that AB and AC are equal. Now prove that angle opposite to equal side and their opposite angle. Opposite angle means this angle and this angle. Opposite to AC and opposite to AB. Prove that these two angles are equal. So what is the data given? In triangle ABC, AB equals to AC. Two sides are given equal. To prove what? Angle B equal to angle C. Two opposite angles we are going to prove equal. Now what should we do? Here you know what? You have learned about once again I write here, you have learned about SAS, congruency rule or criteria. Then you have learned ASA and then you have learned AAS. Okay? Out of these three, we use any one. Now see, here we suppose that let AD is the bisector of angle A. Okay? Let AD is the bisector of angle A and point D is on BC. See, in this way, AD is the bisector of angle A. Bisector, angle bisector. When this angle and this angle are equal, it means angle BAC equals to angle CAD. Call it result number 1. AD is the bisector of angle A and D is on BC. If it is an angle bisector, that means these two angles are equal because it is an bisector. Okay, angle bisector. So this angle BAD and this angle CAD are equal, that we suppose it. We call it result number 1. Now take these two triangles. Which triangle? BAD and CAD. Try to prove that these two triangles are equal. If two triangles are equal, then by simplicity. What do you mean by simplicity? corresponding parts of congruent triangles. If these two triangles are equal, then their corresponding parts are also equal. That means C and B are equal. Simple, that we have to prove. So we take in triangle BAD and triangle CAD, say AB and AC are equal, given AB equals to AC, which is given. From result number 1, we can say what? Angle BAC equals to angle CAD. This is from result number 1. Is it okay? And AD is the common side for this triangle and for this triangle, both triangles. So AD equals to AD. What? Common side. So by side and the side, by SAS congruency rule, now we say that triangle BAD congruent to triangle CAD. If two triangles are congruent, then by simplicity, remaining parts, angle B equal to angle C. Reason is what? By simplicity, hence proved. So from this you can say that if two sides are equal in a triangle, if two sides are equal, then their opposite angles are equal. If AB and AC are equal, then their opposite angle B and C are equal. Now it's converse theorem. Theorem number 7.3, that we accept this without proof, that in triangle ABC, if angle B and angle C are equal, then their opposite sides AB and AC are equal. Okay? In triangle ABC, if angle B equal to angle C, then AB equals to AC. That we accept without proof. This is your theorem number 7.3 without proof on page number 122 it is given. Now we are going to start exercise 7.2. So write down this theorem. We will start exercise. So let us start exercise 7.2. On page number, your textbook page 123. Question number 1. In an isosceles triangle ABC, AB equals to AC, given bisector of angle B and angle C intersect each other at O. Bisector of angle B, when this angle and this angle are equal. Bisector of angle C, that means this angle and this angle are equal. They intersect each other at point O, given. Then show that. So what is the data? First write the data. In triangle ABC, AB equals to AC, given bisectors of angle B and angle C intersect each other at point O. Okay? Prove that. To prove, the first one is OB equals to OC, and the second is AO bisects angle A. Very simple. You know these three criteria, and now you also know that if two sides are equal, then opposite angles are equal. You also accept that if two angles are equal in a triangle, then their opposite sides are also equal. Now see, given what? We start with data. In triangle ABC, AB equals to AC, given. Now from this derive something. If two sides are equal, their opposite angle AB its opposite angle C and AC its opposite angle B are same. So I can write angle B equal to angle C. Right? From theorem 7.2. No need to write that. But if two sides are equal, opposite angles are equal. Now see. BO is the bisector given. That means these two angles are equal. These two angles are also equal because CO is the bisector given. Now B and C are same. So if you multiply both sides by half, then half B equal to half C. Multiply both sides by half. What do you mean by half B according to the diagram? Angle B, total angle B, and its half means OBC. I can write this angle. This angle is the half of B. See in the diagram? Because BO is the bisector of angle B, which is given. Okay, so suppose that angle B is 60 degree, then OBC is 30 and ABO is also 30. So half of B I can write angle OBC. And half of C, similarly, half of C means OCB. OCB. The reason is what? What is given? That BO and CO are bisectors of angle B and angle C respectively. What? Okay, this is given and that's why we can write this. Now call it result number 1. OBC equals to OCB. We derived it. Now see, there is a small triangle OBC. In triangle OBC, from result number 1, angle OBC equals to angle OCB. You have learned that if two angles are equal, then their opposite sides are equal. Therefore, this angle and this angle are equal, so its opposite side this and this opposite side this, means OB equals to OC from theorem by theorem. No need to write theorem number 7.2 because in exam maybe you will forget it. So write only by theorem. So hence proof, this is your first proof. OB equal to OC. Now we are going to prove about that AO. We join AO now. AO bisects angle A. Means we want to prove that this angle and this angle are equal. We want to prove. It means what? You have to prove this if these two triangles are congruent. Which two triangles? OAB and OAC. If you prove that these two triangles are congruent, then naturally by simplicity, corresponding parts of congruent triangles, by simplicity these two angles are also equal. Okay? So, a triangle, in triangle OAB and triangle OAC. AB and AC are same. AB equals to AC given. Two sides are equal. In number 1 we prove that OB equals to OC. OB equals to OC. We proved it. Okay, and AO is the common side for this triangle and this triangle both. So AO equal to AO, common side. Therefore, by side, see, side and this side, side and this side. Is it okay? So by SSS congruency rule, triangle OAB congruent to triangle OAC. If two triangles are congruent, then their corresponding parts are also congruent. So which angle? This angle OAB and angle OAB equal to angle OAC because of by CPCET. Okay? If OAB and OAC are equal, if these two angles are equal, you can say that AO bisects angle A. This is your second number. Sorry. So AO bisects angle A. Hence we prove this, number 1. Now question number 2. In triangle ABC, Diagram is given, figure number 7.30. In triangle ABC, AD is the perpendicular bisector of BC. AD perpendicular and bisector also. So this and this are same. Show that. What is the data? In triangle ABC, AD is the perpendicular bisector of BC. Show that you have to prove triangle ABC is an isosceles triangle. Or prove that in which AB equals to AC. We have to prove AB equals to AC. Means if two sides are equal, then you can say that triangle ABC is an isosceles triangle. Okay, see. AD is the perpendicular, means 90 degree here, 90 degree here, and bisector means bisect BC. It is given. So we start with data. In triangle ABC, AD is the perpendicular bisector of BC given. It means angle ADB equal to angle ADC, and that is equals to 90 degree, and BD equals to CD. Call this to result number 1. Now we are going to prove that AB and AC are same. So you have to prove what? If these two triangles are equal, means prove that triangle ADB and triangle ADC are equal. If these two triangles are equal, then you can say by simplicity that their corresponding sides are equal, means AB equals to AC. So your task is what? To prove these two triangles are equal. So let in triangle ADB and triangle ADC, okay, see, AD is the common side for both the triangle. AD equals to AD, it is a common side. This one is 90, this one is also 90. ADB equal to ADC from result number 1. ADB equals to ADC, reason right angles. And BD equals to CD also. BD equals to CD from 1. So side angle side, side angle side, in this triangle also side angle side. So by SAS congruency rule, you can write triangle ADB congruent to triangle ADC. If two triangles are congruent, then by simplicity you can say that their corresponding parts AB equals to AC by simplicity. And therefore you can write triangle ABC is an isosceles triangle. Is it okay? So write down this. After that we will start number 3.